All right, today we are diving into a really groundbreaking paper. And I mean, this thing could genuinely redefine the future of artificial intelligence. It tackles this massive, hidden cost that's been secretly choking the reasoning power of our best AI models. We're going to unpack a radical new way of thinking that just smashes right through this barrier. And it all starts with one big question.
So let's just start with that. What if an AI could actually think forever? Right now, it's pure science fiction. The reality is, for our most powerful AIs, thinking is incredibly expensive. Every single step in a long reasoning process adds a huge amount of computational weight. So the longer it thinks, the cost doesn't just go up, it explodes. And this isn't just some minor inconvenience. It's a massive wall that stops AI from even touching humanity's biggest challenges. Things like curing diseases or solving climate change, problems that need really long, complex thinking. But what if we've been looking at this whole thing wrong? What if the problem isn't the AI, but the environment we're making it think in?
So here's what we're going to cover. First, we'll break down this crippling AI thinking tax and see why it costs so much. Then, we'll get into a much smarter way for an AI to think, this new idea called the Markovian paradigm. We'll look at the hard data, putting the new method, delete think, right up against the old way. Then we're going to uncover the surprising ghost in the machine, a really cool reason why this all works so well. And finally, we'll talk about what it really means to unlock infinite thought for AI.
Okay, let's get into it. The first piece of this puzzle is what the paper calls the AI thinking tax. Because really, to get why the solution is so brilliant, you first have to understand the sheer size of the wall that AI reasoning has been slamming into. So the way we usually get AI to do complex thinking is something called long chain of thought, or long COT for short. And here's the deal with it. To come up with the very next piece of its thought, what's called a token, the model has to look at everything that came before it. The original question, plus every single thought token it's generated so far. Its entire working memory is the whole history of the conversation. I mean, imagine you're trying to write a book, but for every new word you want to write, you have to go back and reread the entire book from page 1. That's basically long COT. The context just keeps getting bigger and bigger and bigger until it's just impossibly slow and expensive.
And the researchers have this perfect analogy for this. They say the old way, long COT, is like a marathon. You've got one runner, the AI, trying to run a race that's basically infinitely long. But with every step it takes, it has to carry the weight of all the steps it took before. So the burden gets heavier and heavier, and the runner gets exponentially slower. The new way, Think, well, that's like a relay race. You've got a whole team. Each runner sprints a short, fast leg and then passes on this tiny, lightweight baton, just the most essential info, to the next runner who then takes off at full speed. This is the big idea, the conceptual leap that just changes the whole game.
Okay, so that analogy is great, but let's look at the cold, hard math, because that's where things get really crazy. The way modern AI works, a mechanism called self-attention, makes every new token look back at all the old ones. This creates a cost that grows quadratically, which is a fancy way of saying it explodes. Now, say you want the AI to think S times longer. With the old way, long cute, the cost blows up by S squared. Think about that. If you want it to think 10 times longer, it costs 100 times more. 100 times longer, that's 10,000 times the cost. It's a computational and an economic brick wall. But just look at that bottom row. The Markovian approach, the cost only goes up linearly with S, so 10 times longer thinking costs just 10 times more. This is the game changer. It makes marathon-length thinking possible for the price of a sprint.
So we've got this massive, expensive problem. How do we fix it? Well, this brings us to a totally different, way smarter way to think. They call it the Markovian paradigm. The whole idea behind Markovian thinking is actually pretty simple. It's based on this property that says the future only really depends on the present, not the whole past. Think about the weather. To predict if it's going to rain tomorrow, you really just need to know what the weather's like right now. The pressure, the temperature, the clouds. You don't really need to know what the weather was a year ago. So what if an AI could work the same way? What if, instead of its whole chain of thought, it just needed a small, constant-size summary of its current progress to keep going? That is the paradigm shift. It completely decouples how long the AI thinks from how much stuff it has to process at any one time. Its working memory never has to grow.
And you can see exactly what this looks like right here. On the left, you've got the long COT environment. The context bar just gets longer and longer and longer, one never-ending thought balloon. But on the right, that's think. The thought process is chopped up into these fixed-sized chunks. The model thinks inside chunk 1, passes on that little baton, and then starts totally fresh in chunk 2. Which is the exact same size. The context size stays the same no matter how many chunks it uses or how long it thinks for.
So how does this actually work? Well, it's this super elegant four-step loop. Think, summarize, reset, and repeat. Step 1. Think. The model does its reasoning thing, but it's inside a fixed window, let's say 8,000 tokens. Step 2. Summarize. This is where the magic happens. The model is trying to write a short, essential summary of its progress right at the end of the chunk. This is the baton. Step 3. Reset. Now the environment does something crazy. It just deletes everything from that chunk except for the original question and that new little summary. It's a total memory wipe. And finally, step 4, repeat. The model starts a brand new chunk using the question and the summary as its prompt, and the whole cycle just starts all over again. A continuous, super efficient relay race of thought. Now, this all sounds amazing on paper, right? But the big question is, does it actually work? Can you really just wipe an AI's memory every few thousand words and expect it to keep solving hard problems? Well, let's look at the data, because the proof is in the performance. Check this out. This is the Amy Math Benchmark, which is a set of really, really hard math problems. The first 2 bars, that's the old long code method. You give it a bigger thinking budget, from 8,000 to 24,000 tokens, and yep, it gets more accurate. No surprise. But look at that third bar. That's DeliThink. It also has a 24K token budget, but it's working in those little 8K chunks. And it's not just as good, it's slightly better. I mean, that's just wild. It proves you can be way, way more efficient without losing any quality and maybe even gaining some. And when we talk about efficiency, we're not talking about small savings here. We are talking monumental gains. The researchers did the math. They estimated what it would take to train a model for a thinking length of about 96,000 tokens. Using the old long COT method, that's 27 H100 months. And each 100 is NVIDIA's top AI chip, and a month of its time is a massive amount of power and money. With DeliThink, the cost plummets to just 7 H100 months. That's a nearly 4 times reduction. This makes training for super long thinking suddenly possible. But honestly, this next part might be the most mind-blowing result in the whole paper. What happens when you push these models past their training limits? Look at the chart. The long COT models, trained with a certain budget, just hit a wall. Once they reach their limit, they're done. Their performance flatlines. But DeliThink, it's totally different. Because it's learned a repeatable process, it just keeps going. As you give it more and more thinking time, way beyond what it was trained for, its performance just keeps getting better. This is real scalable reasoning. It's not just memorizing a process. It has actually learned how to think. So, why does this work so well, so fast? I mean, you'd think teaching a model to forget things and perfectly summarize its own thoughts would be an insanely hard challenge. Well, it turns out there's this weird, kind of spooky reason it works so well. A ghost in the machine, if you will. Here's what they found, and this is a direct quote from the paper. Models already sample Markovian traces 0 shot. Okay, what does that mean, 0 shot? 0 shot means they do it without any specific training for it. They just took a powerful, off-the-shelf AI model, forced it into this think and reset environment, and it just did it. It naturally started summarizing its thoughts at the end of each chunk so it could keep going, almost like it already knew that was the best way to solve the problem. It's like they have this hidden natural ability to think this way already. So think about what that means. The training process isn't trying to teach the model a totally alien skill from scratch. It's starting from this incredibly strong position. The model already gets the basic idea. The training is just sharpening and optimizing an ability that was already there. It's like coaching a naturally gifted athlete. You're not teaching them how to run, you're just teaching them how to run faster and more efficiently. And that's why this training is so effective. Okay, so let's zoom out for a second and just think about the sheer scale of what this means. This isn't just a neat trick or a clever optimization, it's a fundamental shift in how we think about the limits of what machines can do. Let's talk about what this really means for the future. First off, the idea of an AI thinking for millions or even tens of millions of tokens, that just went from science fiction to a real engineering problem we can actually solve. Second, this basically gives a huge green light to all these new AI architectures that aren't based on that costly quadratic attention, and that could speed up a move to even more efficient models. So what does all this unlock? I mean, just imagine an AI that can read and connect the dots across the entire world's library of cancer research to find new treatments. Or an AI that can grind through a mathematical proof so huge it would take a person a lifetime to check. We are fundamentally redrawing the map of what machine reasoning can do. So we come full circle, back to that first question, but now with a totally new perspective. Have we just found the key to unlimited machine reasoning? For years, this quadratic cost has been this fundamental roadblock, this hard wall. The Markovian Thinker doesn't just chip away at that wall. It shows us a door right around it. By completely rethinking the environment, we might have just removed the single biggest handbrake on the reasoning power of AI. So what happens now that the brakes are truly off? That's the question we're all going to be figuring out for years to come.